For similar polygons, this is our second big topic of today. Polygons with the same shape but different size. Okay, so you can see here, like, these are two triangles. They look very similar, but they have the same shape, but they just have different sizes. Okay, one's smaller, one's bigger. So for polygons that are similar, they have corresponding angles that are congruent. So you can see, like, even this picture here, like, all these angles match up perfectly. They're all the same degrees. So corresponding angles are congruent. Okay, but as we can see, the side lengths that match up are different sizes, right? Like 8 and 12, that's not the same. So that means that corresponding sides are proportional. The ratio of corresponding sides is called the scale factor. If polygons are similar, then their perimeters are also proportional. All right, so for an example, what is the scale factor of triangle ABC to triangle DEF? So go ahead and fill that F in. So for here, we would pick two sides that are corresponding. So we can say 8 and 12. Those are corresponding sides. So we write that as a ratio, 8 to 12. But we know that we can simplify ratios. So 2 over 3. And the 2 over 3 is your scale factor. So then it says, what is the scale factor of triangle DEF to ABC? So same thing, we're going to go backwards. So from the big triangle to the small triangle, if we compare 12 and 8, and we reduce that, we get 3 over 2. But as discussed up here in this bullet, if polygons are similar, then their perimeters are also proportional. So if I look at triangle DEF to triangle ABC, if I were to add all of the sides on each triangle and set up a proportion or a ratio, I would get the same thing as 3 over 2. Because these are the same. For similarity statements, for similarity or similar, you use this little symbol right here. It's like a little squiggle line. A valid similarity statement must match corresponding angles and sides. So as you can see up here, if I said triangle ABC, well, triangle D, so D and A correspond, B to E correspond, and then C to F correspond, so D, E, F. And so if I were to put the little symbol right there, we could say that triangle ABC is similar to triangle DEF. So from example 5, understanding similarity, it says that triangle JKL is similar to triangle PMN. So for your angles, we want to know, what's congruent to angle J. Well, J goes with P. K is congruent to angle M. And lastly, angle L is congruent to angle N. And I just used this statement here to help me figure that out. For your sides, you would say JK corresponds to PN. And it must be congruent to KL over MN. And then that must be equal to JL over PN. Okay. In part B, it's very similar, but instead of having a triangle, you have a quadrilateral, which is a four-sided figure. So again, we're just going to go through our different angles. So J matches up with Q, K to R, L to S, and lastly M to P. And then we set up our sides. So starting with JK, we would go to QR. And then KL to RS. And then LM to SP. And then JM to QP. And so just the big idea is that you would definitely want to use the similarity statements listed here to help us identify this information down here.